What's up, everyone? My name is Cody Engel, and in our last video we were talking about abstract classes. We touched a little bit on how you would create this like abstract function and alluded to overriding different things. And so in this video we're going to give overriding things their own video and kind of talk about that in its own right. And so for that, I just want to do a little bit of cleanup before we get started, because this print function, I really don't want that to be there anymore. So we'll just update that to be print line there, and then option, remove that override, and actually there we don't need it anymore. And then for our random calculator, again, just getting rid of that. We will keep those curly braces though, because for the purpose of this, we are going to talk about how you would override values that are not abstract, but instead are just the class that owns it. My cat sneezed very loudly and scared me. But so the classes themselves, so like our calculator can say, if you want to override this, it's okay. And so for our example, let's say our random calculator is going to do something with the current value. Actually, we're gonna rename this one, or instead of renaming it, we'll delete that. We'll go all out. We'll do what we've been actually alluding to, and we'll say that this is going to be a bad calculator. And the bad calculator is going to inherit from our calculator. But it's not going to it's not going to do anything with the initial value. It's not going to mess around with that. It doesn't give you the ability to have your own initial value, so it'll just start off at 0. But let's say we want to override the current value. Well, you'll see right there it says property must be initialized or be abstract. All right, so 0. And then we'll see, all right, so current value in calculator is final and cannot be overridden. So in Kotlin, everything defaults to being final, which in Java, this is very different if you're coming from Java, because everything in Java is not final. And so what that means is, even going and saying like random calculator, I want to inherit from that. Well, I can't do that because this class is final. We can define it as that, but in Kotlin, this ends up being redundant. And so in order for us to do that, we would have to use the open keyword to say this class is open for extension. We're not going to do that. We're just going to say it inherits from calculator, but we're going to use that same idea and say that the current value is open for extension, and then our current value is equal to 0 in that sense. But we're gonna change it up a bit. So in order to do that, we're gonna delete it for now, and we're going to do. My Mac is freaking out. We're gonna say override again. We're gonna say var or override current value. It gives us this autocomplete, and you'll notice with the autocomplete you now have the ability to say what get should do, and in this case it's calling super.current value. So what super is when you call super, it will call the parent class. So the parent class in this case is calculator, and then set is what happens. So when we say equals initial value, what happens there? What do we do in that case? So our bad calculator is going to set the value to just be double the value. Something that you probably wouldn't want to do, but for this we'll do that. And within Kotlin, when you have these properties, you get this ability to set its backing field. And so in order to do that, we say field equals value times value. And then over here we get property must be initialized. So because we are now saying how it should be done, we'll just say equals 0. Or in our case, we can just say equals super.currentValue. So whatever value you were passing in, we'll do that. And so with that, we can now, test out our bad calculator. So it's not going to be random values, but the values that we provide it will inherently just be kind of like doubling themselves over time. So we shouldn't get what we would actually expect. And so just to highlight that, we'll just give it some simple values. So like 2 plus 2, it should be 4. And then if we subtract, say, 4, it should be 0. And if we, let's say 3, just to definitely avoid being 0. And then we'll say for multiplying, we'll just multiply it by 4, and then adding 1. Yeah, that sounds fine to me. And then we'll go ahead, we'll run our calculator, and we will run our bad calculator. And so we get, 0 plus 2, 0. So we're seeing, we've sort of broken the way that this works. And so because our field, so the value times the value. All right. And so the error of our way ended up being because over here we didn't supply it with its default value. And so because of that, it's just always going to be kind of like perpetually 0. And so we go through, we run it. It's again still going to be perpetually 0. If we delete our get though, and then we go ahead, we run it, we'll see now it actually starts working in the way that we expected it to. And the reason why is, we didn't need this extra, super dot current value. In fact, we can update this now just to say this equals that. And then when we run it, we'll get, so our starting value, so 0 plus 2, and then 4 plus 2. Well, that's not right, but going to here, it actually, that is correct. And then 36 minus 3. And then we just see, over time, it just continues to give us worse and worse results, because every time we set the current value from our abstract class, it runs this code instead. And we can even just, sort of see that by saying this code is bad. So just to highlight even more, every time that we run it, it'll call that this code is bad. Whereas if we just use our better calculator and run it, it doesn't do that. It just runs it as you would expect a calculator to do that. So we'll go back over to our bad calculator. We will come over here. So we're setting it equal to the current value. Let's say that we wanted get to do something different though. So let's say that we did actually want to override the get functionality. So we have our field. We just want to do return field. So that's the default functionality if we wanted to go ahead and run it and have it be a bad calculator and misbehave again. Let's say every time that we return it, we do field minus 1. So in this case, the value that we're returning isn't even the value that is stored in the current value. So we're misleading the users of our calculator even more. And we're saying, so minus 1 plus 2, we can get rid of the print line. We get 0 plus 2, 3 minus 3, minus 1 times 4. So we're just getting not good values at all. And so, we've taken a calculator that could be perfectly good by allowing us to extend the current value functionality from our base calculator. We give people the freedom to create calculators that just don't work. But that's sort of what I wanted to cover with this, just talking about being able to override functionality and calling out what that actually looks like. In practice, you would want to override the functionality to enhance what you were trying to build for your current use case. And I guess in this case where we wanted to build a bad calculator, we were able to accomplish that. But usually you would be enhancing this for less malicious things. You could also say like allow the add function to be overridden and all of that. But the other thing to call out before we finish off this video is really the nice thing about Kotlin is by default, you can't do this. Whereas in Java, by default, you can override anything. If you wanted to restrict the ability of your class that you created from being able to be overridden, you would have to define final everywhere. Whereas Kotlin takes the opposite approach and says, it's a bad idea to allow your class to be overridden arbitrarily without the author's consent. And so with that, if you want anything to be overridden, you just have to either define it as abstract, in which case you're saying, I'm not even giving you the functionality, you have to define it yourself, or defining it as open, where you say, I'll give you this default functionality, and it's okay if you want to change that functionality in any way. It's nice that you have to opt into that as the author of the code. If you have any questions, let me know in the comment section down below. But otherwise, thank you so much for watching. If you enjoyed the video, give it a thumbs up. If you aren't already subscribed, go ahead, hit the subscribe button. And if you want to know when I upload new Kotlin tutorials, hit the notification bell. You'll get push notifications whenever I upload a new video. With that, I will see you in the next one. Again, thank you so much for watching.